Let us look at question 8, Physical Sciences paper 1 grade 12 from November 2022. So question 8 is electric circuits. Let's just get straight to it. Right, question 8. We are given a circuit diagram here. The circuit diagram below shows 4 resistors. So we need to see these 4 resistors here. 4 resistors. Okay, I see we have 1 here, 2, 3, and the 4th one is here. Now, we are told that these resistors are connected to a battery, which is the EMF, and an internal resistance. The resistance of the ammeter and connecting wires, we can neglect them, while the voltmeters have a very high resistance. Okay, now let us look at this diagram here and try and analyze it. So this diagram here, we have our positive terminal here. So our current will move here. We have the total current of the circuit as what? As 3.5 amperes. From here, we have a branch here. So it means that we have a parallel connection. So meaning that from this side, one will come here and then on the other side. But these two are in what? Are in series. So what you normally do, you add the two. If it's series, the RS is equals to 3 plus what? Plus, not even 5, 3 plus 2. So this will be 3 plus 2. So we can take that 3. We have what here? A 2. This will give me what here? Will give me 5 ohms. Okay. So meaning the 5 ohm is in series. In fact, is in parallel with what? With the 1 ohm. And therefore this one is in series here. And we know that here the current that I'm going to have here is going to be the same current I have this side. So what is the current I'm having here? The current I am having here is 3,5. So I have 3,5A, same current here. All right. The first question that we are given is state Ohm's law in words. State Ohm's law in words. Now, for 2 marks in the exam, this is how you're supposed to state it. You're supposed to say the potential difference across a conductor is directly proportional to what? Is directly proportional to the current in a conductor. To the current in a conductor. In the conductor. In the conductor at constant temperature. Do not forget at constant temperature. At constant temperature. At constant temperature. Do not forget at constant temperature. All right. That's how you get, let me just fix that. Temperature, we can take it here at constant temperature. Okay. That's how you get your 2 full marks there. The potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So what are we marking for here in the exam? You should be able to have constant temperature, and you must also talk about the proportionality there, which is directly proportional. Let's go to the next question. We are now told that switch S is closed. Remember, when it is open, no current is passing through. Now the reading on the ammeter is 3,5. We are given that. We are told to calculate the total external resistance. Okay, so I think what we need to find out here, which resistors are external. So 1, this is 1, this is 2, 3, and 4. These are external resistance, and therefore we have our internal resistance here. So what we can do is to look for the total resistance of the circuit. So we can say that we have 1 over R, which is parallel. We can look for the resistor in the parallel section. So it's 1 over R1 plus 1 over R2. Okay, what do we have now? So 1 over Rp equal to 1 over 1 plus, remember I said to you, you must combine these two resistors here, which will give us what? 5. So we can then take 5 as one resistor. So it's 1 over what? 1 over 5. That's what we get here, 1 over 5. And if we punch the two, remember to do the reciprocal here. Don't forget to do the reciprocal. So our R parallel here will be 0.83. But we can just punch this to verify. 0.83. So this will be 0.83. But how do we then get the 0.83? So we come here now. We come here now and use our calculator. Let me just move it a bit here so we can see. What do we have then? We have 1 divided by 5 plus 1 divided by 1. So 1 divided by 5 plus 1 divided by 1. What do we get here? We get 6 over 5. So we get 6 over what? Over 5. Okay? Reciprocal of that. In fact, here we can even change this and say it is still 1 over Rp. So 6 over 5, which will be 5 over what? Over 6. So my Rp there is, I just punch 5 over 6 there. So I have 5 over 6. 5 divided by 6. What do I then get? 0.83. So we have 0.83 here. 0.83. All right, are we done? No, they said we must look forward for the external, the total external resistance. So I'm going to say R total equal to R parallel plus R series. So now I know that parallel is 0.83. In fact, we can fix that here, 0.83. We have RT 0.83 plus 4. We just add the 2 and get our final answer. So this will give me 4.83. You can use your calculator to verify this one, but it is straightforward. So that's how you get your total resistance of the circuit. But here we're told the external resistance. Let's go to the next question, which is 8.2.2 for 3 marks. What are we looking for here? We are tasked to calculate the voltmeter on V1. All right, so V1 is my external resistor. In fact, external voltage. So let's look at that. External voltage, what can we do to get the answer then? We can use Ohm's law. R is equal to V over I, because we have the total resistance. So we have R equal to V over what? Over I. We have the R that we have just calculated now, which is 4.83. Okay, and therefore 4.83, we have 4.83 equals to, we're looking for the voltage. The total current for the whole circuit is 3.5, and therefore V here is the same as 4.83. What do we have this side? We have 3.5. We just punch the 2 here. What do we then get? 3.5 and 3.83. 3.5 and 4.83. In fact, let me just fix this here. We have here this pen now. Just fixed it. We have 3.5. All right. We just punch the 2 here, and then we get our external what? External voltage, which is V1. So we can write V1 here if you want. Let's check what do we get here. What is our answer then here? We just punch now. Okay, we just punch. what do we punch then? We say 4,83, we multiply by 3,5, and therefore we have our answer as what? As 16,92, 16,91 in fact. So it is 16,91, which is volts. So we know our what? Our reading on voltmeter 1. Alright, let's compare the two. How does the reading on voltmeter V2 compare to the reading on voltmeter V1? So here we are given a choice. We have to choose from smaller than, equal to, or greater than. Let us go and compare the two from the diagram, V2 and V1. So we have V2 and V1. Now V1 has the total for the external, and then V2 is part of the external. So V2 can never be greater than what? V1. So let's go check the question now. We know that V1 is greater. So let's check. We are comparing V2 and what? And V1. So V2 is going to be smaller than. So our answer here, you must write in the exam that it is what? It is smaller than. And therefore you get what? You get your 1 mark there. Smaller than. You get your 1 mark there. Smaller than. Okay. Let us continue with our questions here. Now 8.3, a learner concludes that the EMF of the battery is equal to the reading on voltmeter V1. We are not sure if this learner is telling the truth here, but we will find out very soon. 8.3.1. 8.3.1 is a definition again. What are they looking for here? They are looking for EMF. How do you then define the term EMF? The term EMF, it is the maximum work done. So you can come and say maximum work done, maximum work done by the battery, maximum work done by the battery, okay, by the battery per unit charge. So you must say per unit charge. In fact, my pen is doing something here. Per unit charge. Per unit charge. So I can come here and say per unit charge. That's how I define EMF, the maximum work done by the battery per unit charge. So we're looking for maximum work and per unit charge. That is what we call EMF. All right. We come here now, 8.3.2. With 8.3.2, remember the learner made a claim that, we can just look at the learner's claim here. He concluded that the EMF of the battery is equal to the reading on V1. So now the question is the learner's conclusion, in fact, is the learner's conclusion correct? Choose yes or no. So here we can come and say no. The learner is not incorrect. But we must give a reason why is the learner incorrect. This is because remember now they are asking us if the learner is correct. The learner is not correct. Why? Because the battery has what? An internal resistance. The battery has an internal resistance. The battery has an internal resistance. The battery has internal resistance. So what does it mean if a battery has internal resistance? All right, it means that some energy per coulomb of charge or the volts is going to be used to overcome the what? To overcome the internal resistance. To overcome the internal resistance. So the learner's conclusion was incorrect. Okay. We are now moving to the next question. Switch S is now removed. So we are removing switch S and replaced by a voltmeter. We should know that a voltmeter has what? Has a high resistance. Has a high resistance. Voltmeter has a high resistance. Okay, so now we have removed the what there? Switch, and we have a voltmeter. So here before, remember, we had a switch here. Now we have a voltmeter which has a high resistance. Let's check the questions now. How will each of the following change? Choose from increase, decrease, or remain the same. So we are given a choice as well. The power given off by what? By the 4 ohm resistor. So let's check what will happen if this switch is replaced by the what? By the voltmeter. It means that we have a high resistance here, low current or no current at all will pass through here. So meaning that in fact this resistor here is no longer functioning. This section is no longer functioning here. So meaning that I have a what? I have a series what? Series circuit. And we know that with series circuit, if you remove a resistor in parallel, you increase the resistance of the circuit. So increasing the resistance of the circuit, and if the resistor increases, we know that current will do what? Will decrease. Current will decrease, and then P equal to IV. IV, other formula says P equal to VI. So meaning that if current decreases, even the power is going to decrease. So the answer here for 8.4.1 is decrease. Decrease. The answer is decrease here. Why decrease? It is because if you remove a resistor in parallel, you increase the resistance of the what? Of the circuit, and the current will do what? Will decrease because of Ohm's law. Let's move to the next question, which is 8.4.2. They want to know what will happen to the reading on V1. The reading on V1. Now, I normally advise learners here, if you have a question like this that requires you to explain, first explain. In your explanation, you will get the answer whether it's going to increase or decrease. So let's check. Where is V1 now? V1 is the external. All right. So what will happen to V1 if this 1 ohm is no longer taking in current? What will happen now? We know that the current is going to decrease, and if the current decreases, what are we going to have? So look at this. I normally use what we call revive, but my revive spelling is not correct. We have R, we have I, we have V, which is internal, and then V, which is what? External. So this is the resistance, this is the current, this is the V internal, this is V external. So what I know is that what happened is the resistance increase, the current is going to decrease. Remember, according to Ohm's law, V internal has the same current as what? As the current, total current of the whole circuit. So if this one decreases, even VI is going to decrease. What happened to V external? It is going to do what? To increase. So if R decreases, the current increases according to Ohm's law. The very same current that I have is the same current on V internal. It will increase, and then V external will do what? Will decrease. So meaning that my answer here, if I go back before I can explain, my answer there is V external. V external, because we used this one here. V external is going to do what? Is going to increase. So I can go back and say my answer for 8.4.2 is increase. Now let's give a reason for that. So the reason for increasing them, we can come and say, the reason for increasing, we can come and say the first one, the first reason, it is because no current, you can say no current or very little current. Let's say no current is passing through no current is passing through the 1 ohm resistor. The 1 ohm resistor. The 1 ohm resistor. What does that mean now? It means that current will do what? In fact, total resistance will increase. Total resistance will increase. So total resistance increases. Okay, it increases. And then what happens to the current? Current does what? Current decreases. Current decreases. And therefore, what happens to V internal? V internal, in fact, V internal will do what? Will decrease. V internal will decrease as well. And if V internal decreases, it means that V external will do what? Will increase, as I've indicated here. Alright, grade 12s, that's how you answer question 8, electric circuits. I hope you'll do well in your exam.